First, let's talk about agile testing. So, do you think that is there any difference between agile testing and non-agile testing? Like we used to do testing from the day we started software development. Is there any difference between agile way of doing testing and non-agile way of doing testing? Any comment? Like, is the tester life change or the approach for testing change if we change the software development methodology?
So in my opinion, with agile testing coming into picture, the life of a tester has become more tedious.
Okay, because more stressful.
With the continuous integration happening every day, you have to do regression testing every day. You need to do the automation testing. Earlier it used to be a manual-based project. It would be just a manual testing happening and you are done.
Okay.
It has to be now a mix of both the manual and the automation because as your functionalities develop more, you have more things into picture. I mean, running a manual testing on a daily basis really become tedious.
So, if I summarize it,
yeah.
the testers, the job becomes in parallel with the development job.
Right.
So earlier it could be a serial process that first we do design development and then we start testing. But the way agile builds comes into the testing team, it becomes like day-to-day activity. Good starting point, and let's see how the test first approach looks at the testing. Now traditionally what we have been doing, if I have a requirement to code, I will start thinking about design. I will think about, okay, what kind of classes I should be there, what kind of layering I should put into place, what kind of pattern I should use before I will code. That's the normal way we do, and that is called design-driven development. So we make the design, then we write the code, and after that we give the build to the tester. Now, even in so-called agile development, we are still following, many of our fellows are still following the same sequence. They are just doing it fast. Rather than following it for a 1 month, or a 1 year, they may do it in a week. That in a week, we do design, code, and then we push the build to the testing. So that is still a design-focused development approach. Now the test first approach talks about don't design. Start from test. Write the test first, then code, and after that design, or we call the refactor. Looks odd? Is it possible to write the test before even having the real design in place? Yeah, but that is what the test first approach is all about. Now we will see how it can be made practical, but agile testing as per se focuses on let's start thinking about test before we think about design and code. Now, why? Because traditionally we have been testing at the end of the development cycle, be it waterfall, or if you have 3 months or 4 months or 5 months duration project, we used to do testing at the end. A lot of Scrum implementing team is also doing testing at the end, but they are doing inside the sprint only. So like they have a 4 weeks of sprint, 3 weeks they do development, and the last week they are doing testing. So more or less things remain same. They are just the batch size is small rather than having the full 6 months, 7 months kind of batch cycle. Now this approach has a problem because if you find some problems at the last week, it's difficult to improve your code. The feedback which could have been observed well if we receive in the early stage cannot be taken care of when we get it at the last stage. We may take some workaround. If this bug is coming, let's fix it on the UI level so that our iteration can succeed, so that our project can go to the customer. So if we do the testing at the end, it becomes difficult to really take care of the feedbacks which we receive during that testing. The other problem is we always run out of time. So, and the testing teams keeps complaining we get billed at the last day. Okay, so they will keep complaining that, and that becomes the reality. And in the shortage of time, we end up cutting testing. So we end up cutting testing, and it creates future issues, because if you cut testing because of the stress, it becomes a positive feedback loop. So you are cutting testing today, tomorrow when you will get more bugs, that stress level of your project will increase further. So taking compromise or reducing the testing time will generate more and more stress or more and more problem if we look further in our development cycle. Now, the Agile talks about, now many of you are already certified and might have seen some lean principles. Even yesterday I was giving a training in one of the corporate company and people were saying that is this Agile is against testers? Do you want to remove testers from the complete development life cycle? So my answer was that we are not against testers, but we are definitely against inspections. We don't want that testers should do inspection. Why? Because the complete quality process, complete quality movement is more towards prevention. It's more towards build quality in rather than inspect. And that is where the Agile testing also focuses on that we should use good engineering practices. We should have minimum hands-off between developers and tester. Like this one is developer, this one is tester. I need to go through a process before the build goes to the tester. Such kind of barriers should be reduced and testing should be performed every day. And more towards prevention, more towards including the engineering practices which can produce defect-free code. So that is what the Agile testing is all about. That is what the lean way of build quality in principle all about. Now if you look at test automation pyramid, now this is something coming from succeeding with Agile. Now in Agile we expect that maximum automation, maximum effort in automation should be done at unit level. Now traditionally when we start thinking about automation, we expect that we can't automate till the time we have a stable build. You might have heard this, that till the time we don't have a stable build, how can we record the QTP script, how can we do this or that? But if you already have a stable build, then why do you need a testing? You may think that in future, whenever there is something goes wrong, for regression we need it. But that's too late. A lot of time, traditionally we have been investing too much automation here. Agile recommends that maximum testing effort, maximum automation should be invested at unit level, not at UI level. So we in Agile, when we talk about build quality in, we talk about reversing the automation pyramid, the reversing the effort which we spend in various testing activities. Now, so yeah, please.
Just a question. So if we talk from a UI per se, in any ways, I mean, automation would not be of much use when we have something to test from a UI perspective. In any case, it depends upon project to project. So let's assume an example of an e-commerce website where, okay, at the functionality level, at the lower level, maybe this unit testing concept would work. But if I'm making a e-commerce website, my focus on UI would definitely be very high.
True. Now, when we talk about automation, it doesn't mean that UI, and definitely it will vary from project to project as well. But whatever is visible at UI, it is a reflection of what is really working inside. So we need to ensure, for example, in an e-commerce project, is the service tax is getting applied properly? Is the discount coupon is getting applied properly? If we have a discount expiration date, is that getting validated properly? So if we have a unit level detailed test points or whatever you say test cases, which ensures that whenever I change my discount feature, my previous discount logics are integrated at a unit level, at a class level, that adds a good amount of weight in the system. Now what happens, now I will also demo it, in the absence of having a base level automation, the programmer will always remain fearful. So if I need to break the function into 3 functions, because now it doesn't make sense to have such a long function, if I don't have an automated way to verify that breaking is not impacting here and there, I will always remain fearful. And I will keep postponing that decision. Let's keep working with this particular function only. And that will create more and more future spaghetti code. So I will show how it works when we get into the demo of the same thing, but that is a point we can talk about. Now, let's talk about some terms. So this was like a philosophical slide. Now we talk about test first development, and there are 2 concepts which comes into the picture. One is called acceptance test driven development, which Nitin was talking about, that we have an acceptance test cases. Before we start coding, we should think about that how can we ensure once we are done with the coding, this test will pass. The another is test driven development. The test driven development term is primarily more and more linked with the software developer doing testing while developing code, more towards with unit testing. Now, these acceptance test-driven development and test-driven development, they interact with each other. Now, when we start capturing requirement, the ATD flow will start. So, in a agile environment, not necessary to be a Scrum or an XP environment, we expect that we will be capturing requirement in slices. So, the first thing which we do is we discuss the user story with the customer, product owner, business representative, whatever name you want to give it. So we discuss that and then we summarize that test points in the form of acceptance criteria. So we summarize them in acceptance criteria, and then if we follow acceptance test driven development, it is expected that we will also implement automated suite in order to ensure that these acceptance test criteria are passing or failing once we have a running code. So this is like an acceptance test driven development layer where we automate the acceptance test cases. We are not yet at a unit level. Once we automate that, definitely since the code is not yet developed, they will fail. So the acceptance test driven development starts with failing acceptance cases. So we have a failing acceptance cases, and then we talk about let's do the coding. Now when we do a coding, since I spoke about it is test code design cycle, we also write the unit test first while doing coding. So we write the unit tests, we do the real coding, and once we have a running thing, we refactor it. So we keep repeating this cycle till the time my acceptance test starts passing. So before my acceptance test pass, I may go through the multiple cycles of failing and succeeding unit test points. Once I have that, here also I am doing refactoring, but once I have the final acceptance test criteria meeting, I may do the refactoring at the final stage, and then finally I demo it to the customer, and this is how I do the development. Now, it is also summarized in some of the books by way of 4 steps which talks about discuss the requirement, then distill, list down the acceptance criteria in the format which you can refer back, then develop, do the coding by following test code refactor cycle, and then demo it to the end customer. So if we follow this, it is kind of merging acceptance test driven and test driven. Now, if we get into the detail of pure test driven development, it is more to do with the code part. The cycle which I was showing here, this cycle is the one which is primarily referred as test driven development. Now in test driven development, we talk about red, green, clean cycle. Heard about red, green, clean cycles? So we start with red. Now, how we start with writing test cases first? If I have a requirement, rather than thinking about the class, I need to think what test I should write which will make sure that this requirement is developed. So I will think about the test, and then I will implement that test in my unit testing framework. Since my code is not yet ready, when I compile it, even the not compilation is also considered as a fail. So once I have a failing test, then I move to the next step and make it pass. So thinking about the test first, second, make it fail, which is called red. After that, do the coding, make it green, and in the process of doing green-red, you might have overlooked many of the design principles. Then clean it once you are done with making it green. So cleaning is designing. So first time you might have used some instance variables, you might have not used proper classes, you just made it work. Now you have a way to verify it is working. Once it is working, now you think that how should I organize it well? And then you do the refactoring. You change maybe you create a separate function, take some code into separate function, we create a separate class, and that is how your design emerge. So that's the concept which talks about test-driven development. Now there are 3 laws of test-driven development, which talks about that we may not write the production code until we have a failing test. So first I need to write a failing test before I write the code. That's the first law. The second law talks about that you may not write more unit tests than is sufficient to fail. So, and not compiling is also failing. So it's not like that I will write 10 unit test cases, all are failing, then I will do the 10 development. No. So you don't do a development till the time you have a failing test, and you don't write the second failing test till the time the first one is passing. So it has to be doing slices. The third law talks about that you may not write a production code which is sufficient to pass the currently failing test. So it is like doing the development in very, very small pieces. Write a small failing test, make it pass by way of writing the code, and only write sufficient enough to pass that test, and after that refactor your code to make it future adaptable. So these are the 3 laws, and there are a lot of benefits related to TDDs. It ensures that you are writing what is needed. It ensures that you are conforming to the business requirement. Because if you have already written the test scenario where you are making a test code, whatever you will write, it is only to pass this failing test. So you don't go here and there. You remain in the boundaries which is needed by the business. And in the process of making such a small test code, you end up creating a very detailed regression suite. So whenever you have to change one function, if something is breaking, you will came to know. So the future maintainability, the future courage would be high. You will not be worried while refactoring a function because you can detect where it is failing. So that is the benefit. There are various misconceptions about test-driven development. A lot of people think that if we write the code first and or then we do a unit testing, it is also a TDD. A lot of time, even if we follow unit testing, we first write the code and then we do a unit testing. If it is working for you, it may be good, but it is not TDD. And a lot of time we think that TDD is not useful in order to improve the design. So if you really do a refactoring, if you keep the test code at a granular level, you will get good design by using TDD. This one, that it takes too much time. It used to be my misconception also, that TDD is really looks like doing coding twice. Yeah, it is kind of doing coding twice, but if you look overall product life cycle, you will save time. Because going forward, whenever you change something, you have a direct way of capturing that something has broken. In the absence of that, you end up pushing the build to the tester and they will report to you that this particular report is not working because their regression suite has detected somewhere something. Sometimes they miss because they are also running out of time. In the second iteration, you will get to know that this defect has been injected in the previous iteration when we changed the previous code. So you save time by doing TDD, by detecting such issues well early in the process. It's not complex to learn. You will see it's too simple. It's just a matter of changing our mindset from a design-driven to a test-driven. So we will see it is not only something for a small projects. It can work in any type of projects, but definitely as the project changes, the rigor of each concept will change. In some cases, you may have 1,000 lines of test code. You may end up testing each and every line. In other projects, you may have functions which covers 10-20 lines in a one go. So that kind of adaptation is possible. Now, this is a good one, which while I was reading test-driven development by example by Gan Peng, and this line I really liked. He himself he's the one who created extreme programming, where the test-driven development has been taught as an important practice, and he's telling good engineering may be 20% of the project success. So it's not like that if you have a very perfect test-driven development, your project will succeed. So there are only 20% things which makes the engineering makes the project successful. Bad engineering will saturally sink the project. If you have code not working, then you are going to fail. But with a moderate engineering, but if the remaining 80% of things are in place, you still succeed. And that is why we have been succeeding even without doing test-driven development. So in a complete project success, it's not like that if you do a TDD, the project will start becoming successful. It is good engineering, it will make the code maintainable, but you need to know what you have to code. You need to know what is your priorities. So even if you are not following TDD, but if the other things are well placed, you still succeed. So point here is sometimes it may look overkill, but yes, a good engineering ensures that you don't sink because of bad engineering.
Exactly.
Yeah.
This kind of thing in this, maybe people can skip the refactor part. They will say my functionality is working as I expected. I don't want to spend efforts on refactoring.
Now, this is a usual thing which happens when we deal with the business. Now, that is why even in extreme programming and many of the agile things, we talk about technical debt. In order to explain to the business people that, okay, it is really a debt. Now, it's not necessary to pay all the debt. Yeah, if things are working good, if you don't have to change this thing further, you may not pay the debt. But if you need to maintain it in future, then we need to communicate the future maintenance will have interest, accumulated interest of debt. So you need to pay that interest, and that will make your speed down. If you want to maintain it further, and that too frequently, better to keep technical debt controlled. So I am again using word control. You can't. Today's word living debt free may be very idealistic situation, may not happen. So you will have some level of debt always, but it should not exceed your salary. Your EMI should not exceed your salary. So that is something which we need to ensure in a technical debt also. So this is all about concept, and now we can try doing coding for this. So good with the theory? Should we move to the coding? Huh? Good enough?